The problem is, let me show you an image. So I'm going to show you an image here. All right, you should be able to see that. So you see an airplane, and basically if both engines are operating, this airplane goes straight ahead, right? Nothing really, especially if the thrust is equal on them. But as soon as you lose an engine, then you have one engine developing, like let's say this one, a lot of power, and this one developing nothing. And because the C of G is somewhere in here, I wish they kind of would have put that here. So, or I guess CLCG in here, then it's going to turn, or it's going to cause a yaw change, right? So this airplane is going to rotate to the right, like it says here, right? It's going to do that. And when it does that, the way you're going to stop it from doing that, because you don't want that to happen, right? You don't want to just go uncontrolled to wherever this thing takes you. So you're going to stop it by deflecting rudder. So you're going to press on the pedal. So this is going to cause a turning force to the right. You're going to press on left rudder. That's what you're going to do initially to stop this yaw. So the thing to get in your head here is that all works pretty good, right? We can stop the yaw of the rudder. But the problem with this is as we get slower, or as its conditions change, but let's just talk about speed just for a second. As we get slower and slower, then we need more rudder to offset this force, right? Because this control is becoming less effective because it has less airflow over it, right? So, and you'll get to a point called the VMC speed where you won't have enough rudder to overcome the yaw, and the airplane will then roll, it'll yaw off in the direction eventually roll, right? And there's some other things which we'll talk about. That's basically what happens in a nutshell is you run out of rudder.